Okay, y'all, today we are talking about writing the equation of a rational function given the graph of a rational function. We are going to start off and do all of our notes here for this lesson in the lab manual. This is part 2 of the section rational functions. We're given graphs, and again, we're just trying to write the equations. Let's start with A here. So the way we're going to do this is we're going to write down and we're going to take information from the graph, right? So we're going to look for all the stuff that we've used as sort of landmarks for our graphs when we were graphing. So things like asymptotes, holes, and intercepts are going to be really helpful. So let's start that off here. What do we have? What can we see? Well, we definitely have a horizontal asymptote at y equals 1. We also have a vertical asymptote at, what is that, x equals -3. I don't see any holes here, so no holes, but we do have an intercept right here at 0, 0. That is both an x and y intercept, right? Both x and y, right? Because it's where the graph intersects both the y-axis and the x-axis. There are no other x-intercepts, so that's our only intercept that we have for the whole function. So let's give this a shot. F of x here. We know it's going to be rational, so let's go ahead and write that sort of fraction line. Okay, so first of all, what does our horizontal asymptote tell us? Our rules were these guys. We either have a smaller degree on top, which gave us a horizontal asymptote of 0, the same degree on the top and the bottom, which gave us a horizontal asymptote of y equals the ratio of the leading coefficient over the leading coefficient, or we had a slant asymptote. What do we have here? We don't have a y-intercept of 0. We don't have a slant asymptote. So we must have this case in the middle, where we have the same degree on the top and the bottom, and the leading coefficient over the leading coefficient is equal to 1. So that tells us that we have the same degree on the top as the bottom. We don't really know what our degrees are yet because we haven't looked at anything else. So let's continue onward but we do know that our leading coefficient over our leading coefficient is 1 over 1. So we can write that here for now just to sort of keep track. So we have a leading coefficient of 1 on the top and the bottom. Vertical asymptote x equals -3. Where do we typically find vertical asymptotes? Well, it's something we have to take out of the domain. So definitely going to come from the denominator, right? Because it's going to be a place where we have x equals 0 in the denominator. That means we want, well, if x is -3, then that gives us a factor of x plus 3, right? X minus -3 from the vertical asymptote. Now, our horizontal asymptote tells us that we have the same degree on the top as the bottom. So we have one factor underneath so far, which means we need to have one factor on top, too. Let's see if we can figure that out from our intercept. So when we had an x-intercept, right, this is both an x and y-intercept, when we had an x-intercept, that came from the top because we wanted the function to equal 0. We wanted the numerator to be 0, but not the denominator, in order for the value of the function to be 0. So if we have an intercept at 0, 0, it means we have x minus 0 on top, which we typically write as x. So we have x over x plus 3, and this is everything. We have the leading coefficients of 1, which we don't have to write. We have the same degree, so we have all the right stuff for this horizontal asymptote, and everything else is checked off. So this is our answer. Let's try C next. Okay, so what do we have here? We have a lot more going on for this one than we did for the last one. What do we have? We have two vertical intercepts, vertical asymptotes. One at x equals, looks like -3, and one at x equals 2. We have a horizontal asymptote at y equals 0 this time. We have a x-intercept at, looks like 1, 0. And we have a y-intercept that we can't quite determine. But we have one. It looks like it's approximately a quarter, right? 0.25 maybe. But we can't say for sure. We don't want to make guesses. So we'll see if we can use that to our advantage. Okay, last but not least, we have no holes, so that doesn't give us any more information. Let's go ahead and start writing. So we have f of x equals, let's draw this line again just to start us off. Starting with our vertical asymptotes, we have vertical asymptote x equals -3, which gives me a factor underneath of x plus 3, right? X minus -3. And x equals 2 gives us a factor underneath of x minus 2, right? Remember, those vertical asymptotes go underneath because we take them out of the denominator, right? It's where the function is undefined. Horizontal asymptote of 0. Well, revisiting our rules, we should have a horizontal asymptote of 0 when we have a smaller degree on top. So that tells us that we're going to have less than 2 factors on top, right? Less than 2 roots on top, so that we have the proper scenario. We can keep that in mind as we move forward. We have an x-intercept this time at 1, 0, positive 1, 0. That's going to give us a factor on top but not underneath, right? That's the rule. X-intercepts are factors, give us factors on top but not in the denominator. So we have x minus 1 on top, and we know that we should be okay there because we're supposed to have a smaller degree on top than underneath. Okay, so now we don't really know too much about the leading coefficient, but we do know we can use our y-intercept, sort of, to kind of check and see if this is it. And what we can do is we can actually just plug in 0 and see if we get something that looks like it could be right about there. This isn't a foolproof method, but for this question it's going to be fine, and you won't have a question that's this vague on the test or anything. Okay, so if we plug in 0 here, that's asking us for f of 0, which is 0 minus 1 over 0 plus 3 times 0 minus 2, which gives us -1 over 3 times -2, which ends up with 1/6, positive 1/6, which means that by this formula, our y-intercept should be 0, 1/6. Does that look like it could be about right? Yeah, totally, because 1 is right here. So this is half. That's about 1/3 of a half, which is 1/6. So this is our function. If we had gotten a value like 3 or something totally different that didn't look like it matched up, then we would need to figure out what this leading coefficient was here to match up with it. But since it does match up, then we're totally done. Okay, let's continue on to B. I know I'm doing them out of order, but just trying to keep things in line here. Okay, so this is the first one that we've looked at that has a hole. Kind of small hole, so I'm going to make it a little bit bigger so we can really see. It's right there. So Where do we have horizontal and vertical asymptotes? Well, horizontal is at y equals 2. We have a vertical asymptote at x equals 5. This time we have a whole at -5, 1. And we have both an x and y intercept at 0, 0. Okay, let's go ahead and start writing this function out. Our horizontal asymptote tells us that since it's not 0 and since it's not a slant asymptote, tells us that we're working with a function that has the same degree on top as on the bottom. So however many factors we end up having on top needs to match the number of factors underneath. It also tells us that the leading coefficient over the leading coefficient is 2 over 1. So we have a leading coefficient of 2 on top, and we can go ahead and write the 1 underneath, just kind of as like a placeholder, I guess. We also know that our vertical asymptote is going to give us a factor of what underneath? X minus 5? Okay, now we have a whole at -5, 1. So there are two things we need to do here. First of all, because we have the x value of -5, it means we have a factor both on the top and on the bottom, right? We have a whole whenever we have repeated factors, right? The same factor in the numerator and the denominator. So we have a factor of x minus -5 or plus 5, both on top and underneath. So that's first. What does the 1 tell us? Well, we can do what we did last time with that y-intercept, which is sort of check at the end to make sure that everything's, a-okay. So we'll hold off on that for just a second. Our intercept is at 0, 0. So that means we have an x-intercept of 0, which means we have a factor of x minus 0 on top. So let's use this whole to check and make sure that everything's all good here. Remember, 1 is going to be the value of the function after we've simplified the function, right? After we've gotten rid of the repeated factors. So we have f sub s of -5, we want to plug that in to see if we get 1, equals 2, we're going to skip this repeated factor, right? We're going to skip x plus 5, times -5 minus 0 over 1 times -5 minus 5, and then this x plus 5 is left out, right? We're leaving out, we're simplifying these repeated factors. So we end up with 2 times -5 over, well, 1 times -10. That, of course, will give us -10 over -10, which is 1. That's what we were looking for, right? We wanted to make sure we got this y value. So this is our function. We could write it like this, but I'm going to simplify a few things, right? I'm going to leave out this 1 and also write x minus 0 as just x. So it just makes it look a little bit nicer. Over x minus 5 times x plus 5. And that's our answer. Okay, now that we've worked through those three, why don't you guys pause the video, work through this last one, part D here, and I will run through it real quick when we come back. Okay, this is what I got. We had a horizontal asymptote at 3, vertical asymptotes at -5 and +6. And x-intercepts both at 0 and 2, and that x-intercept of 0 also, of course, was a y-intercept of 0. So the horizontal asymptote at 3 told us that we had the same degree, so I knew to be expecting the same number of factors on the top and the bottom. And I also was able to write that ratio of leading coefficients, right? 3/1. Then from my vertical asymptotes, I knew I had factors of x plus 5 from x equals -5 and x minus 6 from x equals 6. Then my x-intercepts, which come from the numerator, gave me x minus 0 for 0 and x minus 2 for 2. I rewrote that here, which isn't completely necessary. Again, it just looks a little bit nicer. I wrote that factor of x minus 0 as just x, and then I got rid of that 1 out front because it's unnecessary. One thing I want to mention before we finish up is that finding the equation of a function with a slant asymptote can be pretty difficult, and that's not something that you guys would see on a test. Yeah, so you can expect for us to have just horizontal asymptotes for the questions that y'all will see. Okay, that's all I have for finding the equations of rational functions given a graph. Thanks for watching, y'all.